Welcome one and all to Group Greatness, which consists of Jerry Green, Jaron Fraser, Charles Kovaya, and myself, Akif Fernandez. We are here at the Eastern Caribbean Institute of Agriculture and Forestry, also known as YAHP, located at Centeno, Trinidad and Tobago. We have conducted a field inspection, which we have discovered 3 hazards, which are trip and fall hazard, electrical hazard, and biological hazard. We have assessed the hazard using risk assessments and recommended and demonstrated the control measures of each hazard individually. Let's take a look.
Hi, I'm Jerry Green and we are located at the sheep pen, and we have identified a shovel in the middle of the walkway, which we have recognized as a trip and fall hazard.
According to OSHA.com, this is what a trip hazard is. Officially, OSHA's trip hazard height is 1/4 inch. Any change in floor level that is 1/4 inch or more constitutes a tripping hazard. Examples of common tripping hazards include uncovered hoses, cables, wires, or cords across walking surfaces, obstacles or clutter on walking surfaces, furniture drawers or doors left open, unmarked steps or ramps, damaged or irregular steps, rumpled carpets or mats or curl edges, thresholds, gaps, and other irregularities in walking surfaces, speed bumps, and curb drops.
We have risk assessed it as high risk due to the fact that it's major injury, because you can twist your ankle or sprain your hand from the impact of the fall. And the likelihood is likely because even though it appears to be visible, it's low to the ground and the majority, but everyone could miss it.
As you can see here on our risk assessment matrix table, we have circled that the consequences for the trip hazard is a major injury. The likelihood is likely, so we have discovered and assessed that it is a high risk, as Mr. Green has pointed out.
Now I shall demonstrate.
The control measure used for this particular trip hazard that we have selected from the hierarchy of controls, as you can see circled, is to eliminate the hazard from the workplace entirely. How we did this, we simply removed the shovel and placed it in its correct storage area.
I am Jaron Fraser. We are located at one of the storage buildings, and here is an electrical socket, which is an electrical hazard.
An electrical hazard is any condition that presents a risk of injury or death from electricity. This includes situations where there is a potential for electric shock, contact with live electric parts, burns from electric arcs or heat generated by electricity, fires or explosions caused by electrical equipment and malfunction or overheating. Common examples of electrical hazards include damaged electrical cords or outlets, overloaded circuits, exposed wiring, improper grounding, working on energy.
We have assessed it as an high risk, as it is possible to fatal injuries because of the high voltage surging through the socket, and is unlikely, but not highly unlikely to happen due to the fact that even though it's under shelter, it is still exposed to weather and can be short-circuited by the rainwater.
As you can see here on the risk assessment matrix, we have assessed that the electrical hazard is a high risk due to the fact that the consequences are fatal and the likelihood is unlikely. Consequences are fatal because an electric shock can cause death. It's unlikely because even though it is a socket, it's just not covered. And that is our conclusion. Thank you.
The control measures for this is simply replacing the uncovered circuit and with a new covered one.
This is an explanation of control measures for an outside open electrical socket and why we chose this specific control measure. An exposed auto electrical socket presents a significant electrical hazard due to potential contact with water weather elements and unsuspecting individuals. Here are some control measures that can be implemented, categorized by the hierarchy of controls. Elimination. The most effective control measure is to remove the hazard entirely. In this case, this would involve disconnecting and removing the electrical socket. Substitution. If removal is not feasible, replace the exposed socket with a weatherproof covered outlet. We have chosen this hierarchy control for our identified hazard. Engineering controls. This involves isolating the hazard, install a weatherproof box, or enclose around the socket to protect it from the elements. Administrative controls. Implement procedures to minimize exposure. This can include warning signs about electrical hazard or restricting access to the area. Personal protective equipment, PPE. While not ideal, rubber gloves and boots could be used as a last resort if necessary, but they do not eliminate the hazard. It's crucial to prioritize the higher levels of the hierarchy for maximum effectiveness and safety. Eliminating or substituting the hazard is always preferred over relying on engineering controls or PPE. By implementing these measures, you can significantly reduce the risk of electric shock, fire, or injury associated with the exposed outdoor electrical socket. And as you can see here, out of all the hierarchy of controls, we have selected the substitute or modify the hazard by replacing it with something less dangerous. We have selected this as we think this is more feasible and economically correct. Hi, I'm Charles Govaya, and we're here at the feed storage building at YAHP Farm. We have identified here a biological hazard in the form of rats, which has infested the farm here. This is a biological hazard due to the fact that rats can cause or infest and give us the disease called leptospirosis. This is a fatal disease. A biological hazard, according to OSHA, is an agent that can cause disease or infection in humans. This includes bacteria, viruses, fungi, parasites, and their associated toxins. Exposure to biological hazards can result in a variety of health effects, ranging from mild illnesses to severe, even fatal diseases. Leptospirosis is a prime example of a biological hazard transmitted through contact with the urine of infected animals, primarily rats. Humans can contract leptospirosis by coming into contact with contaminated water, soil, or food. Symptoms can range from mild flu-like illness to severe kidney and liver damage. Industries at high risk for exposure to leptospirosis and other biological hazards include agriculture, waste management, and construction. OSHA has specific regulations in place to protect workers from exposure to bloodborne pathogens and other infectious diseases, which can be adapted to address leptospirosis risks. Due to that fact, we have assessed this risk as a high risk because of the fatal disease and the likelihood of getting that disease. As you can see here on the risk assessment matrix table, we have placed the biological hazard as a high risk because it is a fatal consequence and a likely likelihood. The control measure for this is by placing these rat poison boxes strategically throughout the farm, hoping to kill the rats and stop the biological hazard. So these are the control measures for the biological hazard, the rat infestation, and why we chose this particular control measure. Elimination. While ideal, complete elimination of rats is often impractical. However, reducing the rat population is crucial. Substitution. This is not applicable in this context. Engineering controls. Physical barriers. Sealing entry points to prevent rats from entering buildings is a vital engineering control. Sanitation. Proper waste management and food storage can reduce attractants for rats. Poison rat boxes, as chosen on YAHP farm. These are considered engineering controls as they involve the use of a physical device to eliminate the hazard, rather than removing the hazard itself. While they reduce the rat population, they do not eliminate the root cause of the infestation. In conclusion, our inspection at YAHP farm identified trip, electrical, and biological hazards. We assessed the risks and implemented control measures following OSHA procedures and basic health and safety principles. Remember, a safe work environment is essential for everyone.